Alright, and welcome to dividing by difficult irrational expressions. Now you'll notice what's going to make this difficult is not really the expression, because we've seen this before, but it's actually going to be the numerator. And we can say that there are two terms in the numerator. And this actually just makes things a little bit more difficult. So notice we want to multiply by the conjugate. And we want to multiply by the conjugate because we are trying to rationalize the denominator. And so we know the conjugate of 8 minus the square root of 3 will be 8 plus the square root of 3. And whatever I multiply the bottom by, I have to multiply the top by. Okay. Alright, so let's go ahead and let's start doing our multiplication. We see here that 3 times 8, and we're going to use the FOIL method. We're going to multiply the first terms. 3 times 8 is 24. And then we're going to multiply by the outside terms, 3 times the square root of 3. And let's see, 3 times the square root of 3 will be plus 3 square roots of 3. And here, let me use a different color. Now we're going to multiply the inside terms. We have 6 times the square root of 5. Well, guys, what's 6 times 8? Since both of these are outside of the square root, we multiply them. 6 times 8 will give us plus 48 square roots of 5. And lastly, we're going to multiply by the last terms, 6 square roots of 5 times the square root of 3. Notice the 6 and the 1 in front are what's on the outside. So we'll have plus 6 square roots of, and here we multiply by the insides. 5 times 3 will be 15. And I just really had to squeeze that in. Y'all have my apologies. Okay, let's go to the bottom. Let's switch up our colors. And let's say, okay, well, what's 8 times 8? 8 times 8 is 64. What is 8 times the square root of 3? Well, that's plus 8 square roots of 3. I'm going to switch colors again, just so y'all can really see this. Now we're going to multiply the negative square root of 3 times 8. So this is really a negative 1. Negative 1 times 8 is negative 8 square roots of 3. And lastly, guys, we have this. We have the negative square root of 3 times the square root of 3, which we know is the negative square root of 3 squared. So remember, anything times itself is really being squared. Square root of 3 times square root of 3 is the square root of 3 squared. And now it is up to us to go ahead and start simplifying. Now you'll notice something right here in the top. This is the easiest version of this when these square roots right here are different. When you have the square root of 5 times the square root of 3, you'll notice that we have the square root of 3 right here, we have the square root of 5 right there, and the square root of 15 right there. These things are not going to simplify. And since they're not going to simplify, we can begin to write our final answer as such. We can say, okay, we're going to have 24 plus 3 square roots of 3 plus 48 square roots of 5 plus 6 square roots of 15. That stays entirely the same. But notice here on the bottom, the plus 8 square roots of 3 minus 8 square roots of 3, those will cancel. And over here, the square root of 3 squared, the square root and the square cancel. And what do we really see here? We really see here on the bottom 64 minus 3. Now, I'm going to go ahead and simplify this by just erasing, but ask yourself, what is 64 minus 3? Well, of course, that's going to be 61. Now, I would then ask myself, can I reduce 61, 24, 48, 6, and 3? But 61 is a prime number, and so since 61 is a prime number, it's really nice. It tells us that it cannot be reduced. All right, let's move on to our second example. Okay, for example 2, we see here 2 minus 4 squares of 2 all over 10 plus the square root of 2. But I want y'all to notice something here just initially. Notice that in the denominator we have the square root of 2, and in the numerator we have the square root of 2. So if these two things are going to be the same, we're going to have a lot more simplification, okay? So just know that up front, you're going to have a lot more steps in this. Well, let's go ahead and start by first multiplying by the conjugate. And I would ask you to pause the video and write down what you think the conjugate is. And it turns out the conjugate is going to be 10 minus the square root of 2. And when we multiply the bottom by, we have to multiply the top. Okay, so let's go ahead and start multiplying. Remember, we're going to use our FOIL method, and I'll use kind of 4 different colors here. So for our very first term, the 2 will be multiplied by 10. 2 times 10 will give us 20. And 2 times negative square roots of 2 will be minus 2 square roots of 2. Let's switch colors. So now we're going to multiply this term, negative 4 square roots of 2 times 10. Well, guys, negative 4 times 10 is negative 40 square roots of 2. And negative 4 square roots of 2 times the negative square root of 2. A negative times a negative is a positive. And 4 times 1 is 4, and the square root of 2 times the square root of 2 will be the square root of 2 squared. Let me write a better 2 in there. Okay, the square root of 2 squared all over, and here we'll do the same thing for the bottom. Okay, using a different color, let's go ahead and switch to a nice orange. Oh, I'm sorry, let's switch to a nice green here. We have 10 times 10, which is 100. We have 10 times negative square roots of 2, which is negative 10 square roots of 2. We also have, let's use a nice red, the square root of 2 times 10, which will be positive 10 square roots of 2. And lastly, we have the square root of 2 times the negative square root of 2, and a positive times a negative is a negative, and the square root of 2 times the square root of 2 is really the square root of 2 squared. So you're going to notice there's going to be a lot more simplification here. So let's kind of start out with the top, okay? And I'm going to go ahead and do the top in this nice shade of purple. Here, we see that the 20 does not have any more just kind of normal numbers or integers they can combine with, constants. So I'm going to go ahead and write 20 right there. But I see a negative 2 square roots of 2 minus 40 square roots of 2. Since this is the square root of 2 and that's the square root of 2, we can treat these like terms. And so negative 2 minus 40 is negative 42 square roots of 2. Now lastly, notice we have 4 square roots of 2 squared. Well, let's cancel that out. The square root and the square cancel. And so we're going to write plus 4 times 2. So you'll notice there's a little bit more simplification that needs to go on there. All over. Now let's kind of just show a distinguishment here. We're now talking about the bottom. We have 100. And here we have negative 10 square roots of 2 and positive 10 square roots of 2. And of course those cancel. And the square root of 2, or I'm sorry, the square root and the square cancel. And we have minus 2. Okay. Now I want you all to see one other thing here. 4 times 2, let's just call that 8. And now we can begin our second to last simplification. Okay. So what do we have? We really have 20 plus 8, because that's a positive 8 there, and 20 plus 8 will be 28 minus 42 square roots of 2 all over 100 minus 2 will be 98. And the last thing that we want to do here is we want to reduce. Okay? We have to reduce. Now, I kind of look at 28. I know 28 can be divided by 4 and 7 and 2. I look at 42. 42 can also be divided by 7. Let's see, can 98 be divided by 7? Can 98 be divided by 7? It can. Okay, so since I believe all of these things can be divided by 7, let's go ahead and do that. So 28 divided by 7 is, so I'm just going to put kind of a big little sign here where we're going to divide everything by 7. 28 divided by 7 is 4, minus 42 divided by 7 is 6, square roots of 2, remember we only divide the start, all over, and let's see, what is 98 divided by 7? Oh, and that is going to be 14. Okay, and notice we can actually reduce this one more time. Reduce one more time. Here, everything 4, 6, and 14 can be divided by 2. And let me kind of erase this little start here so we got the room to write this. But yeah, our final answer is going to be 2 minus 3 square roots of 2 all over 7. Alright, so guys, it's just a long process with the arithmetic, but other than that, it's not like the multiplication is difficult. all you have to remember is just our trick of multiplying by the conjugate. Alright, good luck, and I'll see y'all in our next video.